Hello everyone, I am Dr. NAVNEET KAUR, Associate Professor in Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology, College. Today I'll be taking lecture on the subject Signals and System. The topic which I'll be discussing in this lecture is Z transform. In my previous lecture, I have already discussed the basics of the Z transform. The formula and the properties of the ROC were discussed in my last lecture. Now, in this lecture, I'll be taking some examples of calculating the Z transform of sequences like right-sided sequence, left-sided sequence, and both-sided sequence. Now, I'll start with the first example, which is taking right-sided exponential sequence. Now here we have any signal xn, which is given as a raised to power n un. Since un term is there, so this sequence is non-zero only for n greater than equal to 0. And it is 0 for n less than 0. So it is right-sided sequence. Now, if I want to calculate the Z transform of this given sequence, I'll take the formula of Z transform. Summation n is equal to minus infinity to infinity, a raised to power n un, which is the given signal, and z raised to power minus n. Since un is there, so my limit will change from n is equal to 0 to infinity. And the value of un in this range is 1, so I'll write 1 in case of un. Now I'll be left with a raised to power n and z raised to power minus n. So I'll take az inverse raised to power n. Now, if I'll consider this sequence and I'll put values of n as 0, 1, 2, 3 till infinity. Now, I'll see that I'll get a geometrical progression which is infinite. Now, here first term is obtained when I'll put n is equal to 0. So I'll get 1. Then I'll put n is equal to 1, I'll get second term, which is az inverse. When I'll put n is equal to 2, I'll get third term, az inverse raised to power 2. So the common ratio for this geometrical progression will be az inverse. Now for convergence of xz, we require that this summation should be less than infinity. So region of convergence is the range of values of z for which az inverse, which is the common ratio, will be less than 1. Now, if I'll calculate this, it will be a by z less than 1 and z greater than a. And if I'll calculate the value according to the formula for infinite GP, I'll get a upon 1 minus r, where a is the first term, which is 1 here. 1 minus r is the common term, which is az inverse. So if I'll solve it, it is z upon z minus a, and ROC is z greater than a. So here, if my pole is located at z is equal to a, ROC will consist of the region which is outside the circle of radius z is equal to a. So here I can see that this is the z plane, this is the real z, and this is the imaginary z. Now, poles are located here, which is z is equal to a in this case. So I'll draw a circle which will be having a radius of a. Now, as ROC says that z is greater than a, so my ROC will include this region which is shaded gray here. So ROC will be the outside of the region of this circle which is having a radius of a. So we will get the ROC which will include the unit circle if a is less than 1. Now, I'll consider second example, which will consist of the left-sided exponential sequence. Now, I'll take sequence xn, which is minus a raised to power n u of minus n minus 1. If we'll plot u of minus n minus 1, I'll get a sequence which will start from minus infinity and end on minus 1. That means this sequence is a left-sided sequence. So it is non-zero only for n less than equal to minus 1. Now, using the formula for Z transform, xz will be minus a raised to power n u of minus n minus 1 and z raised to power minus n. Because there is a term u of minus n minus 1, my limit will change from minus infinity to minus 1, a raised to power n, z raised to power minus n, because this u term will be 1 for this range. Now, minus n is equal to 1 to infinity, because here I am taking, say, n is equal to minus n. So limit will be 1 and infinity for minus infinity and minus 1, a raised to power minus n, z raised to power n. Now it can be written as 1 minus summation n is equal to 0 to infinity, a inverse z raised to power n. Now this second term will be a geometrical progression, which is an infinite series, and the common ratio is a inverse z. So if I'll solve this, I'll get z upon a less than 1, which is z less than a. Now by calculating this expression, 1 minus 1, a upon 1 minus r, where a is the first term, which is 1 here. 1 minus r, r is the common ratio, which is a inverse z. Now by solving, I'll get z upon z minus a, but ROC is now z less than a. So if I'll take the z plane, this is real z, this is imaginary z. I'll get a pole at z is equal to a, and I'll draw a circle. The ROC will include the region inside the circle, which is having the radius of z is equal to a. So here I have seen for right-handed sequence, the z transform was z upon z minus a, but ROC was outside the circle of a. Whereas for left-sided sequence, again z inverse is z upon z minus a, but ROC is inside the circle of radius a. So here, this is the summarized form, which we have already calculated. Xz is z upon z minus a in case of right-sided sequence, and ROC is z greater than a, and Xz is z upon z minus a for left-sided sequence, and ROC is z less than a. So the algebraic expression of pole zero pattern does not completely specify the z transform of a sequence. So here we can see that ROC should also be specified for any signal. Now we will consider two-sided exponential sequence. That means here the sequence will consist of right side part and left side part of the y-axis. So minus 1 by 3 raised to power n un, it consists of n is equal to 0 to infinity part of the signal, and minus half raised to power n u of minus n minus 1, it will consist of the sequence which will be for n less than equal to minus 1. We have already calculated in my previous slide that the ROC of this part is 1 upon 1 plus 1 upon 3 z inverse, and ROC of this part is 1 upon 1 minus half z inverse. This is right-sided sequence, so here ROC will be z greater than 1 by 3, and this is left-sided sequence, so ROC will be z less than 1 by 2. Now, if I'll calculate this z transform, 1 upon 1 plus 1 by 3 z inverse plus 1 upon 1 minus half z inverse, upon calculation, I'll get the final result here. Now, for finding the ROC of this whole sequence, I'll take the intersection of these two ROCs. So here, if I'll draw a z plane, this is real z, and y-axis shows imaginary z, I'll take two poles, which is z is equal to 1 by 3 and z is equal to half, and I'll draw the two circles at z is equal to half and at z is equal to 1 by 3. Now, ROC is the common region. So, for z greater than 1 by 3 means that the region outside the circle of z is equal to 1 by 3. And z less than half is the region inside the circle of z is equal to half. So the common region will be the ring of this part, which is between 1 by 3 and 1 by 2. So ROC will be z region of z, which is greater than 1 by 3 and less than 1 by 2. So this will be the ROC of the two-sided exponential sequence. So these are some popular Z transform pairs which are commonly used. The Z transform of delta n is 1 and ROC is the all values of Z. Z transform of un is 1 upon 1 minus Z inverse. ROC is Z greater than 1 because this is a right-handed sequence. minus u minus n minus 1 gives 1 upon 1 minus z inverse, but ROC will be z less than 1 because this is left-sided sequence. ROC, Z transform of delta n minus m will be z raised to power minus m, and ROC will be all z except 0 if m is greater than 0 and or infinity if m is less than 0. Now this is all for today's lecture. Thank you.